Good afternoon. My name is Jong-gi. I'm in charge of the Rail Solution Division at HYUNDAIROTEM. It's my great pleasure to meet you all here in Germany, a global leader in rail transport technology. We are now 3 years into the pandemic. Hopefully this will all come to an end soon to bring back much needed momentum to the global rail market. After a 4-year hiatus, InnoTrans is finally back, and we'd like to take this opportunity to set out our new vision for rail transport. The world is in the midst of a major paradigm shift toward a low carbon future with zero emissions and green energy. In response to this trend, the global rail industry has been exploring eco-friendly rail transport solutions based on carbon-free power sources such as hydrogen. Today, we'd like to share with you our latest developments on this front. First, I'd like to introduce you to Won-sang Lee, Vice President of the R&D Center. He is in charge of developing the hydrogen fuel cell tram. Please welcome.
Good afternoon, everyone. My name is Won-sang Lee, and I oversee hydrogen tram R&D at HYUNDAIROTEM. Carbon neutral has become a global buzzword, with more and more countries pledging to meet net zero targets. The rolling stock industry will also have to align with transition by 2050. This is likely to involve phasing out diesel trains and replacing them with trains powered by hydrogen, the ultimate clean energy source for the future. Hydrogen is the most abundant element in the universe, accounting for nearly 75% of its mass. It is the smallest and lightest element, but it is essential for the future of mankind. It is the future of rail. For starters, hydrogen is eco-friendly. Fossil fuels such as oil and coal produce large quantities of carbon dioxide when combusted, which contributes to global warming. But hydrogen makes water when combined with oxygen. There is no emissions, and therefore no pollution involved in the process. Also, it saves a lot of money. Hydrogen train can operate without overhead power cables. So, you can save costs associated with building and maintaining power supply infrastructure. In addition, hydrogen is an energy source that can be used in a long-term and large scale. This has to do with its energy density, which is significantly higher than that of batteries. In fact, hydrogen is the only viable option for rail industry, which requires an independent energy source for high volume movements over a long period of time. Driven by this benefit and green energy trend, countries with advanced rail systems are rushing to introduce hydrogen trend. Against this background, in January 2019, HYUNDAIROTEM took on a new challenge to usher in a so-called hydrogen society. We developed a hybrid fuel cell battery combination based on Hyundai Motor Company's hydrogen fuel cell technologies. I installed this system on a prototype tram to demonstrate its feasibility and had its performance verified through a driving test. At the earlier stage of development, we faced several challenges, including a lack of technical standards and institutional support. This was followed by a multitude of trials and errors. But backed by a special initiative of Korean government, we are finally able to complete successful test one in March 2021. In July 2021, we built on this experience to launch a new project aimed at developing a production-ready hydrogen train. Funded by Korean Ministry of Trade and Industry and Energy, this ongoing R&D project is joint effort of 21 leading companies and research institutes in hydrogen technology in Korea. It is also joined by a municipal government looking to introduce a hydrogen tram service. This means technology can be easily translated into a real-life application once we finish testing it on demonstration lines. This project has an ambitious goal to produce a production-ready model at the end of 2023. Korean researchers are strongly committed to making this goal a reality. So, we will be able to see hydrogen tram running through the streets of Korea by the end of 2023. Yes, next year. The underlying technology behind the hydrogen tram is a hydrogen fuel cell. It is mounted on the roof of the tram, and it is the same system that powers Hyundai Motor Company's passenger car, such as Nexo, as well as its commercial vehicles, including buses and trucks. The technology has a proven track record of performance and safety. Together with the Hyundai Motor Company, we plan to leverage advanced hydrogen technology and tailor and upgrade them for layered applications. This will allow us to equip trams with the next generation lightweight hydrogen fuel cell with enhanced durability, robust power output, and increased life expectancy. We are also involved in the development of key technologies for hydrogen locomotive as a follow-up to the hydrogen tram. There are growing needs for eco-friendly rolling stock at home and abroad. We intend to develop concept design for hydrogen rail cars, locomotives, and high-speed trains to cater to these future demands. From 2024 onward, we'll start diversifying our lineup of hydrogen vehicles. Now, when it comes to hydrogen train, you can't forget about hydrogen production and refueling technologies. After all, without the technologies to extract hydrogen at high purity and store and refuel it, hydrogen trains simply can't run. In fact, hydrogen production is the starting point of hydrogen rail transport and an enabling technology for a zero-carbon hydrogen society. If we are to use hydrogen as an energy source, we need high-purity hydrogen. HYUNDAIROTEM possesses a technology to extract high-purity hydrogen from natural gas or biogas. Once hydrogen is produced from byproduct gas, it is loaded on a hydrogen tube trailer or transported through pipelines for delivery to hydrogen refueling stations. The use of byproduct hydrogen as an energy source that would otherwise be discarded is environmentally friendly. This is also expected to help increase the supply of hydrogen. As you can see, HYUNDAIROTEM looks to advance hydrogen project with its proprietary technologies. This plan includes Trade Power's hydrogen fuel cell, a hydrogen generation system, a hydrogen distribution center. And these hydrogen projects will accelerate our transition into a green leader in a carbon neutral future. At this point, we would like to walk you through our flagship hydrogen project. First, allow me to introduce our senior researcher, Mr. Shin Park, who will shed light on the hydrogen trend.
Hello everyone, it's really great to be here. My name is Shin Park and I'm responsible for the development of the hydrogen power train. You can see this commercial model on display over there. Hydrogen trains are powered in the same way as a conventional electric train. The only difference that hydrogen trains do not require pantographs and over-catenary wires because electric energy is generated on board by hydrogen fuel cells. Hydrogen fuel cells generate electricity and water and through a chemical reaction between hydrogen stored on board tank and oxygen in the air. Okay, let's forget about all those fancy chemical formulas for a second here. In addition, air in the atmosphere passes through a filter and leaving a particular matter behind. This purifying feature alone is environmentally friendly. And what's more, hydrogen fuel cell emit water and zero carbon dioxide, which explains why hydrogen trains are the ultimate green means of transport. One train set would have 4 95 kilowatt hydrogen fuel cells. 2 of them will be installed at both ends of the train, and battery packs with high power charge and discharge capability placed in the middle module. So, in total, we would have 2 different power sources that gives each other redundancy in case of a failure. When starting, the train will be powered by hydrogen fuel cell, and as it accelerates, the battery will work as a parallel power source to produce the needed electric energy. And when braking are applied, the energy generated by traction motor is stored in the battery for energy recycling. Also, there are 4 PMSM traction motors at each end of the train, meaning we have total 8 high output, high efficiency traction motors. Thanks to this robust power system, our train can travel up to 150 kilometers on a single charging. I hope this gave you better understanding of our hydrogen train. If you have any question, please come see me at our booth here. Well, let's wrap up my presentation. Now, we'd like to talk about our hydrogen production and refueling infrastructure. Please welcome our senior manager, Kim, with a big round of applause.
Hello everyone, my name is Kim, and I'm here to give you an overview of the infrastructure needed for the production, storage, distribution, and refueling of hydrogen. As mentioned earlier, at HYUNDAIROTEM, we have the capacity to build not only hydrogen trains, but also hydrogen production and refueling infrastructure. We offer solutions across the entire hydrogen value chain, from hydrogen production and refueling to hydrogen-powered vehicle development. You can see our hydrogen reformer and hydrogen refueling system on display over there. First, let's take a look at the hydrogen reformer. This system extracts hydrogen from natural gas or biogas and is the key component of hydrogen refueling infrastructure. It is slightly larger than a 40-feet container in size, but is capable of producing 300 normal cubic meters of hydrogen per hour and 640 kilometers per day with a purity of over 99.995%. So compared to its rather small size, the production capacity is incredibly high. By simple calculation, 640 kilograms per day is enough to fill up over 100 hydrogen passenger cars. Building on small-scale reformer technology, we are now developing a high-efficiency system for large-scale hydrogen extraction. Second, we have the hydrogen refueling system right next to it. This is the hydrogen distribution center, which is a central hub for the supply and distribution of hydrogen. Once produced, hydrogen is stored in a buffer tank before it is compressed and stacked on a tube trailer for delivery to hydrogen refueling stations. At these stations, you can refuel hydrogen trains. We offer a range of refueling infrastructure solutions, including on-site, off-site, and mobile stations that are tailored to specific customer needs. We also provide internally developed dispensers for optimized hydrogen refueling. As you can see, HYUNDAIROTEM offers a full range of integrated solutions for hydrogen rail, from large-scale production of quality hydrogen and its safe distribution to refueling station to rail vehicle powered by hydrogen. In terms of hydrogen infrastructure, besides the refueling solutions that I just covered, we are also exploring new possibilities in green hydrogen, including a hydrogen liquefaction system to ensure large-scale storage and improved transport efficiency, as well as a solar-powered water electrolysis system. Well, that's it for my part. Thank you for attention. I'm going to pass it back to Mr. Kim.
Thank you. That was a quick overview of what we have been working on so far and what we wish to accomplish going forward. Hydrogen trains are an eco-friendly means of transport, producing zero emissions. They offer a green alternative to diesel trains that run on non-electric lines. They also help to avoid high installation and maintenance costs of power infrastructure, such as catenary and substations. To captivate the market and green potential of hydrogen, HYUNDAIROTEM will take on the lead in creating hydrogen transport options. In a follow-up to the tram model shown today, we plan to expand our lineup of hydrogen vehicles to include multiple units, locomotives, and high-speed trains. By 2024, we plan on developing an intercity multiple units model with improved output and increased hydrogen payloads. By 2030, we will unveil a locomotive model and high-speed train model that will deliver an increased range based on high-power fuel cell technology. Achieving net zero is a global imperative, and we, as the global rail community, have a responsibility to deliver an innovative, green, and emission-free rail transport solutions, including those based on hydrogen. Thank you all for joining us here today, and I hope everyone enjoys the rest of the sessions at InnoTrans. Thank you.